Welcome to Mastering Solutions. In this general problem, we'll be comparing how much longer it takes to swim downstream and upstream if there's a current versus how long it takes to do that if there is still water. Let's write down, of course, the equation for velocity, which is the change in x, or d for distance, divided by the change in time. In this case, we're talking about the time, so let's isolate that. So we're going to multiply both sides of the equation by time. So we have delta x now is equal to velocity times delta t, and then we'll divide both sides of the equation now by velocity. So we have the change in time is equal to delta x over the velocity. So now we need to talk about the current because we have to factor that into the time. So if we have the time with the current, we're going to have the distance, which is the same, and that will be the velocity that we're swimming in the water plus the velocity of the water. Now, if we are swimming against the current, we'll do against is equal to the distance, which is the same, of course. And now the velocity that we're swimming minus the current fighting against us, the velocity of the water. So now we have these two, and let's write an equation to simplify the overall concept of what we're doing in this problem. So let's give a little bit more room. The total time that it took us to do it with the current as a factor divided by the total time if it was just still water. So let's break this up. So we're really going to take the time that it takes us to do it with the current plus the time that it takes against the current. And then that divided by, of course, the time if it was just still water. So now we can plug in these expressions that we just found up here into our equation right there. So let's give some more room again. All right, so to do this, we're going to have the distance divided by the velocity plus the velocity of the water plus the distance, this one's against, so velocity minus the velocity of the water, the current. All of that will be divided now by 2d divided by the velocity. This one, the distance that we went is we went down and we went back, and it's divided by the speed that we did. Here, we still have our 2d on the top, but we broke it up because we had to factor in the current on both sides. So now obviously, since this is a fraction, we can multiply by the reciprocal, which is v over 2d. So now we have to simplify this expression since we're multiplying by that. So let me rewrite this to better show what we're doing. So we have v over 2d, and we're multiplying that by d over v plus vw plus d over v minus vw. So now we can take this one step further. So let me erase this and redraw this just so we don't have to write it again. We're going to pull out the 1/2. So 1/2 times v over d, because this is the same thing as what we just did, v over d. So now when we simplify this, the d's will simplify. And let's write that again, because these steps can get really confusing if you don't show all the steps. So now we have 1/2 times v, because it's essentially v over 1, because we simplified the d. Let's get rid of that though. Okay, so now times v times 1 over v plus vw plus 1 over V minus VW. Okay, some more room again. So now if we rewrite this equation, V is essentially, of course, V over 1. So as we multiply this to here and to here, that gives us 1/2 times V over V plus VW plus V over V minus VW. Now this can be simplified further because if we multiply the top and the bottom of both of our fractions by 1 over V, 1 over V, same thing over here, 1 over V, that gives us 1/2 1 plus 1 plus VW over V plus 1 over 1 minus VW over V. So as you notice in the equation here, the distance was the same every step. So we were able to simplify that out of the equation. So the only thing that mattered was the velocity that we were swimming and the velocity of the current. So now when we plug our numbers into this final equation, after all of that, we have 1/2 multiplied by 1 over 1 plus VW was 0.52 meters per second, divided by, we were swimming at 1.78 meters per second, plus 1 over 1 minus 0.52 meters per second and 1.78 meters per second. So we have 1/2. Now 1 divided by 1 plus 0.52 divided by 1.78 plus 1 divided by 1 minus 0.52 divided by 1.78 gives us 1.093. 1.093. Now what is that? So remember, we're comparing the ratio of, if we come back up, the distance, or rather the time of the current divided by the time with no current. So if we have a number greater than 1, that means it took longer with the current. So if we look at this, it's 0.093 longer. So if we move that over 2 to give us a percentage, it took us 9.3% longer to swim with the current as a factor than if we were to just swim the same distances with still water. So the answer is it takes us 9.3% longer to swim with the current as a factor as opposed to if we did the same distance swimming without current in still water.